We focused on structural mechanics in the previous tutorials. This time we're going to perform a heat transfer analysis so you get an idea of how this is done in Abaqus. The setup consists of a copper block with its two ends held at fixed temperatures of 400 degrees Celsius and 350 degrees Celsius. One half of the top surface is exposed to a heat flux of 5000 watts per meter squared, which will raise the temperature of the block. The other half of the top surface is exposed to air at 200 degrees Celsius, where it loses heat by natural convection. We will assume that the convection coefficient is 13 watts per meter squared per degree Celsius. We will assume there is no heat loss by radiation from this surface. One half of the left side of the block is in a vacuum and inside of another cooler body at 320 degrees Celsius. Heat transfer occurs between the two bodies only by radiation. The copper is assumed to have an oxide layer and therefore has an emissivity of 0.78. All the other surfaces of the block are insulated, meaning that no heat flows across these surfaces. You're probably thinking to yourself, this is a really strange setup, but it allows us to demonstrate how to add conduction, convection, and radiation heat transfer to your model without any other distractions. The dimensions of the block are displayed in the figure. The SI system of units is used where length is in meters. The temperature scale being used is the Celsius scale. The block is made of copper with a thermal conductivity of 401 watts per meter per degree Celsius. There are two types of heat transfer analysis, steady state and transient. In steady state conditions, the temperature differences and heat fluxes driving the heat transfer remain constant with time, and a state of equilibrium is reached where the spatial distribution of temperature does not change with time. A transient state, on the other hand, is characterized by variations in body temperature with time. In this example, we are going to perform a steady state analysis, which means that the heat transfer process has been taking place for a while, and an equilibrium state has been reached. So open up Abaqus and let's begin.